All right, I'm going to show this areas of limit problem. The students that did the practice exam from the AP people, this was one of the practice exams they gave was how to do the area the long way. If you remember, I showed you guys how to do derivative the long way. The limit of f of x plus h, and it's annoying. Um, but I also showed you when we did a review, probably day 3 or so, I showed you areas of limit. Now, most of you looked at me with a deer in headlights, like, "What the heck? It's complicated," but it's how integrals came to be. So it's taking an integral by definition. So, in a sense, so what we're doing here is this is the actual question over here that they asked. I'm going to do that in just a second. Here's an example I put in your notes to show you this. Okay, so when you look at this areas of limit, this is one way to write it. It's how I wrote your notes, and then this is the same problem written another way, which I'm going to explain. The key is you have what you're really doing. Let's say is you're doing left rectangles. So what happens is instead of doing 5 subdivisions, you're doing n infinite subdivisions as n approaches infinity. So what happens is the more subdivisions you do, the more accurate you are. If we do infinite subdivisions, we'll get the exact answer, and that's what an integral is. So this is where integrals come from. You're looking for one thing that was factored out of everything, the 2 over n. What that 2, if you remember, is how far apart the numbers are. So there's an integral, they're 2 apart. Could be 1 to 3, could be 5 to 7, I don't know yet, all right? Now the way the formula is set up, you'll see inside a function, some number plus 2 over n. The same width will be there. This is where you're starting with. So see how it says 3 plus, so that means where 3 is our starting, because it consistently says 3 plus. Now, this is the width, which is 2 over n, and so that means we're going from 3 somewhere. So the next rectangle will be 2 over n, and then another 2 over n will be 4 over n, as you can see. That's our rate. So it's from 3 to 5, because the gap is 2. Since they're 2 apart, and we're starting with 3 is what that's saying. So now it's 3 to 5 of what equation? Well, whatever this is in is your equation. The 3 plus, what? Like if you were to substitute, pull that out, what would you replace it with? Like if you replace it with an x, you'd see x to the 5th power. So this is asking you, hey, what's the integral of x to the 5th power from 3 to 5? So you guys could actually give an answer and finish this in integral. Now this is saying the same thing, but in a more condensed fashion. Now, when I teach it, and when the textbook I learned from, they use the letter I. And if you look up here, they use the letter K. Who cares? It's just a letter. So I'm going to show it with I just so you guys don't go like, why is it K? Who cares? So here's I from 1 to n. The limit is n approaches infinity. So technically, we're just saying from 1 to infinity. You can see how the gap is 2. Instead of listing them all out, 6, the notes I did, 2, 4, 6, n, they could just say I. What that is when I is 1, it's this one. When I is 2, it's 3 plus 2 over n times 2. That's where the 4 over n comes from. So this one is more of a condensed way of saying the same thing. So that will lead us to this problem. So you guys were given this practice problem, which said, hey, you look at all this and go, oh, you immediately should say, I need to take an integral. That's what you're saying. All right, the limit as n approaches infinity from k or whatever. So you look at the main part. Now I did it here in blue. Hopefully you guys can see that pretty clearly. It says -1 plus. So we're starting at -1. Well, the actual problem that they were given said, hey, we're starting at -1. That's your lower bound. So they actually helped you out, which was nice. All right. So, but I'm saying you guys can get it from here, -1. Now, see how it says 5 over n and the width is 5 over n? That means the gap is 5 spaces. So -1 to 4 would be your integral, because it says start at -1 with a gap of 5. All right? Now, you take this out and it just says h of x. So they want the integral of h of x from -1 to 4. You're like, okay. Well, they gave you a picture of the graph of h. Oh, so they want me to take an integral from -1 to 4. So we know an integral of a picture is just the area. So this is the actual picture. So you have a little tiny half of a box here. So that's area's a half. It's just from -1 to 0 there. Now this triangle, I could have done one big triangle, but I broke it into 2 triangles because this one kind of meets in the middle here. So I did a 3 by 1, half base times height, you get 3 halves there. Now this is a 1 by a half, so half times 1 times a half is a quarter. It's because it crosses right in the middle. If you're not sure it crosses in the middle, just based on slope. Slope is rise or run, so remember it's a 2 to 1 ratio, all right? So the rise is 1 over a half would be 2. 1 over a half is 2. And that's kind of how you know it's a half there. And then this one's the same one over on this side. So if I'm going to take an integral from -1 to 4, well, I got a positive a half, but then I got a -3/2, so I'm down to -1, and the 2 quarters, one's below, one's above, cancel each other out. So the answer to the problem is -1. So they're just saying, hey, what's the limit of this? And it looks so complicated, you just want to skip it. But it's really just saying, hey, let's take the integral from -1 with a gap of 5, -1 to 4 of whatever's in here. Typically, they'll give you an equation, but this one they gave you a symbol, h of x, and then gave you a picture just to do something different, kind of a unique little problem. So I will add that problem to my notes. It's going to be for the future years because it's a really good one. All right, so that's areas of limit, and hopefully that helps.